Hello, good morning, everybody. It's time to start the second day of our webinar. So, exchange of experiences on LCA for waste management and material flows in Satakunta. So this is Transnational Learning Journey number 3 of our LCA4Regions project. And we will have a very interesting day today, an important day, so we will hear the good practices presentations from all our project regions, and this is a very important part of the product outcomes, and we have several interesting presentations. And now this morning, first of all, I just wanted to remind you all to keep your microphones unmuted during the presentations, and after for discussion and questions. So we will have time after the first session. The first session will consist of 4 presentations, and I hope that you can ask questions only after these 4 presentations. We have reserved time for that, and then we will continue with the other other presentations then afterwards. So without any more discussion at this point, so we will go to first to Portugal. So Elsa is there. Yes.
Yeah.
Hi, Elsa.
Hi, good morning all, and thank you for being here and for having the time to take a look at Portuguese good practice. I'm going now to try to share my screen.
Please.
Okay. Just a moment. And that's it. Well, I'm going to share with you this good practice that is called Green Edge. In Alentejo region, including Baixo Alentejo, of course, there's a long tradition in vine and olive grove cultivation, and the waste from this culture comes from pruning activity, and it is estimated that in all Alentejo region there are around 205,000 tons a year that have no use. Green Edge overall aims at promoting the valorization of this material from pruning vineyards and olive groves, transforming into briquettes and biomass pellets in Baixo Alentejo region. The Green Edge unit was the first in the Iberian Peninsula to work with woody material coming from pruning. Well, Green Edge was established in 2015 with the opportunity and the aim to valorize this agricultural residue. Besides not having any use, these wastes have negative effects on the environment and on the culture itself, and cause increased costs in its removal and burning to the farmer. Green Edge started its activity in the valorization of dried olive pit for use in central heating equipment in public and private buildings. In 2017, Green Edge launched a new project, the Green Edge Eco Pellets, aiming at the valorization of the waste coming from pruning vineyards and olive groves. The construction of a new industrial unit occurred in parallel with the implementation of an organized waste collection network at the pruning sites. vineyards, and olive groves. This network acts as a vehicle for obtaining the necessary raw material without additional costs for the farm owners. And at the same time, it also serves as an aid to the progressive reduction of the spreading and burning of prunings by the farmers. So besides the technological aspects, we have here the importance of this network to collect the necessary raw material. The inclusion of technological advanced equipment studied and selected in a careful way enables Green Edge to transform what is now on what was usually waste without any beneficial use into a product with added value that can be exported and that contributes to create wealth and employment in Baixo Alentejo. Green Edge has several clients in Portugal and also exports to, for instance, Netherlands, Belgium, and Germany, and offers a wide range of products like biofuels, eco-pellets, products for pet care, and fuels for cooking that are especially suited for the Mediterranean diet. So they are aimed at smoking and grilling. This innovative organizational model adopted by the company and based on this creation of a waste collection network requires a high level of planning, and this high level of planning is achievable, namely with the support of IT tools, and is also supported, and it also is necessary to have a high capacity of articulation during this process because, of course, collection of pruning is made according to certain specific calendar. This project could easily be a reference and a starting point for a new innovation-based, high value-added, foreign market-oriented sector of the economy, solving not only an environmental and economic problem, but also enabling wine growers and olive growers to boost their projects and their businesses. And of course, this project could easily be replicated in any other regions since there is high volume of pruning waste. This innovative organizational model adopted by this company and based on the creation of a waste collection network directly in the olive groves and vineyards of Alentejo region, making available to the community a service of high economic and environmental value should and could, of course, be easily replicated. And this is, let us say, one of its most relevant aspects, this possibility of replicability, since we know that so many olive and vineyards are there, not only in Portugal, but throughout Europe. So I leave you here the website so you can pick up more information on this project, on this Green Edge project, and also the hashtag so you can follow what's new regarding to the Green Edge project. So this was my presentation. Thank you all for listening. And of course, I will be more than pleased to welcome your questions and answer them as efficiently as I can. So have a nice session, you all.
Thank you, Elsa. I see that we are in a good time, so I didn't need to remind you to keep in time. So if there's some, I think that if somebody has something now in mind, so I think we may utilize this time here for now, or then in the question sessions we can come back to Elsa's presentation. But otherwise we can continue, and I have pleasure to have Lucia Rigamonti from Milan, I guess. Are you? Yes, you are online.
Yes.
Yes, happy to see you. And you will be talking about LCA and LCC of CDV management system. So please, you can go on.
Okay, thank you. I will try to share my screen. Can you see the presentation?
Yes, yes, we can see.
Okay, perfect. Okay. So, good morning, everyone. So my name is Lucia Rigamonti, and I'm a senior researcher at the Department of Civil and Environmental Engineering of Politecnico di Milano. And I'm here to present you the best practice of Regione Lombardia, that is about the application of the life cycle thinking approach to the construction and demolition waste management system implemented in the region. So we are talking about the construction and demolition waste, but we know that is a big flow in Europe. We know that the Waste Framework Directive has set a recycling target that is of 70%. And recently we have some programs and initiatives aimed at fostering the transition towards the circular economy in this sector. So the government of Regione Lombardia has chosen the life cycle thinking approach to assess and optimize its own construction and demolition waste management system. In this good practice, we have two projects. The first one was done in 2016 and 17, and it was the application of the life cycle assessment methodology to evaluate and improve the environmental sustainability of the construction and demolition waste management system in Lombardy. And this was conducted in collaboration with Mater, that is a research center in Piacenza, inside the LEAP laboratory. And now ongoing is the evaluation of the economic sustainability of the system by applying the life cycle costing methodology. And this is part of a PhD project of Federica Carollo, and it is in collaboration with ENEA. So in both the studies, the analysis include all of the processes from the moment the waste enters the regional system until it leaves the system as a secondary resource, so as a new resource thanks to the recycling activities, or as final emission to the environment. In addition, in the LCC, so in the life cycle costing, we have included also the demolition step, because during the LCA, we realized that the quality of the recycled aggregates is strictly connected with the quality of the waste that enters the recycling plant, and the quality of this waste is strictly connected with the way of demolition. So this is why in the LCC that is ongoing, we have decided to include also this step. The aim of the studies was first of all to highlight both the good aspects and the critical issues along the entire value chain. And after the identification of the critical issues, our aim was to identify the possible improvements based on environmental and economic considerations, and with the final aim to give recommendations to the regional government to maximize its resource efficiency. So as I told you, the first study was an LCA study, and for this we used for the quantification of the amount of waste that are generated and treated in Lombardy. We use the data that are present in the so-called MOOD database, that is the database that includes all the yearly waste declarations. And whereas for the inventory, so for the modeling of the system, we went to visit many plants, and also we get data through some questionnaires, because in this case, it's really important to have primary data in order to model the system that is under study. So in this kind of study, we cannot use literature data or average data, because to have then the possibility to give good recommendations, we need to model the system as it is in the reality. So we need the primary data. In the life cycle costing, as I told you before, we have included also the demolition step. And in this case, for the data collection, we have prepared two questionnaires, one for the demolition companies and one for the recycling plants. And in both of them, we asked data about, for example, the preliminary cost. So the cost for the preparation of the demolition site, in the case of demolition companies, or the cost, for example, for the land purchase in the case of a recycling plant. We ask for the cost for the machinery acquisition, for the diesel and water consumption, for the labor cost, and the cost for the transportation and the delivery of the waste. And in the case of the recycling plants, both for the flows in input and the flows in output. And in some cases, these are not costs, but are profit. So in the life cycle costing, we are talking about cost in euro, whereas for the LCA, we evaluated 13 environmental impact categories that you can see here, together with an energetic indicator and an ad hoc built indicator for the evaluation of the consumption or savings of natural resources, and in particular sand and gravel. So with the LCA that is already finished, we were able to identify the hotspots of the construction and demolition waste value chain in Lombardy. First of all, we identify a deficiency in the treatment of some specific waste streams, in particular the gypsum-based waste. We realized that there is that the market of the recycled aggregates is unstable, and on average, only the 70% of the recycled aggregates that were produced in 2014 were also sold. If the recycled aggregates are not sold, this means that they are not used. So this means that we do not save sand and gravel, and so the cycle is not closed. And why this market is so unstable? For different reasons. For example, because in Lombardy we have a large availability of natural aggregates and also low prices of these natural aggregates. Because also of some cases of the low quality of the recycled aggregates, and so this means that they can be used only in low-grade applications, and also because of the low knowledge and diffidence by the users about the characteristics and the technical properties of the recycled aggregates. So how to solve these issues? So the study, the end of the study is not this one, but from here we define some possible future scenarios, and we have included in these possible future scenarios some changing in the system to, and then we repeated the LCA to understand if these actions, if these changes are really improvement actions. And so after this, we were able to give the recommendations to the region. You can find some of them here. They are grouped in three big groups. So first of all, first recommendation was to foster the market of the recycled aggregates. And here you can see some of the recommendations. So first of all, to make an effective implementation of already existing regulatory tools, maybe also to increase the tax on mineral extraction or to update the sector's technical instruments to the European standards. Second group of recommendations was to promote the production of high quality recycled aggregates. And to do this, we suggest to make more use the selective demolition, because with this selective demolition, we can have a waste that is more clear. And so this means that we have recycled aggregates of better quality. And also to upgrade the existing construction and demolition waste recycling plants, because most of them now are fueled by diesel instead of electricity, and this was important in the environmental impact. The last group of recommendation was to optimize the waste management system, in particular to minimize the waste transportation and also to limit the intermediate waste management steps. And this is achievable, for example, by the creation of a platform to facilitate the match between the supply of recycled aggregates and the demand. And after this, so Lombardy region took some actions. For example, about the last point, the region, together with ARPA, they have created a new section in the database also, that is the one that is used for the collection of the data about waste. And in this new section, the producers of the recycled aggregates can include the information about the amount and the characteristics of these of the recycled aggregates that they have produced. So this is a tool that facilitates the match between the supply and demand. About the issue of the low knowledge and diffidence by the users, Regione Lombardia, together with ANCE, promoted some seminars for the institutions, for the operators, and the engineers. And then also recently, Regione Lombardia has established two incentives aiming at so economic incentives aiming at promoting selective demolition and recycled aggregates utilization. And so we will see with the LCA if the value that is put in these two new regulations is a good value, or if it needs a revision. So these good practices can be extended also to other regional contexts, can be used to evaluate our waste management systems. And for example, Lombardy region has applied already this approach for the evaluation of the municipal waste management system, and also for the e-waste management system. So this approach is really useful and can be applied to every kind of waste management system. And also this study can be can provide guidance for our regional governments interested in improving the sustainability of their own waste management system. They can use the methodology, the recommendations that we give in this study. Challenges, we see that we saw that there is a long process in time for the data elaboration about the waste generation flows. So this has to be taken into account when performing a study like this. Also, the data collection for the creation of the inventory, so for the modeling of the system, is a challenging step, because as I told you before, if you want to have a good inventory, this means to have primary data, and obviously because collecting primary data is time consuming. And about the life cycle costing, now we have seen that there is also a problem of confidentiality. So the demolition companies are not so happy to give to give this data. And then the last point is that to perform a study like this, so to put in practice this good practice, obviously it is necessary an expertise, a good expertise in the life cycle methodology. Here you can find some publications if you want to know more about these studies. And here you can find our contact. Thank you.
Okay, thank you, Lucia. Very nice presentations. Very complete picture, and very nice to see all the efforts done in Lombardia in this respect. I hope so, and we are in a good time. I hope that you can stay online later.
Yes.
So that about 11 o'clock. So we will have this. If anyone wants to ask any questions concerning your presentation. So, and I think that yes, we will continue. And now we go to Slovenia. So Albin, yes, you are online.
Hello.
Hello, nice to see you, Albin. And yes, your presentation is titled Comparative LCA of Alternative Packaging Materials for Beverage. So yes, please go ahead.
Okay, thank you very much, Pekka. Good morning, dear colleagues and dear participants of this webinar. I'm going to talk today about the comparative life cycle assessment of alternative packaging materials for beverage. This is the work which has been done in the field by my colleagues, Damian Kranz, Zorka Novak-Pintaric, and Zdravko Kravanja from the Faculty of Chemistry and Chemical Engineering of the University of Maribor in the northeastern part of Slovenia. Packaging, as you all know, makes an important contribution to the impact of the final product on the environment, and there is even more. Often the life cycle of packaging is even longer than the product itself, which exhibits afterwards greater environmental impacts than the product itself. In this respect, packaging is one of the more intensively studied areas of life cycle assessment. And this analysis can be used to evaluate the environmental impacts of packaging throughout the life of the packaging, from the extraction of raw material, I mean the production of packaging, through the processing of materials, production, distribution, use, repair and maintenance, and as well as finally disposal or recovery. With LCA analysis, we are able to determine which are the key process stages of a product that have the greatest impact on the environment. Because the analysis focuses on the entire life cycle, this prevents the burden of the environment from shifting from one phase of the life cycle to another. LCA analysis is increasingly recognized as a tool for improvement and innovation and a way to reduce environmental impacts. In line with trends, we expect that the use and thinking about LCA in leading Slovenian companies, as well as in the public sector, will intensify in the coming years. Those companies that have already set out to carry out an LCA analysis often face a number of practical issues regarding the implementation itself. Therefore, with this study, we want to promote LCA analysis as currently the best method for assessing environmental impacts and mitigate the complex image of such analysis. And the purpose of this practice is to assess the potential environmental impact of disposable beverage packaging available on the Slovenian market. The goal of this practice, as mentioned before, done by my colleagues from Maribor, is to present assessment of the potential environmental impact of 3 packaging systems. These are PET bottles, glass bottles, and aluminum cans. And the functional unit of the study was defined as the packaging necessary for filling and distribution of 1,000 liters of filled beverage. And the reference flow of product system included the actual beverage packaging, labels and closures, transport packaging, that is reusable bottle boxes, corrugated trays, shrink wrap for disposable containers and pallets. And 6 indicators of potential environmental impacts were considered in the described analysis, like global warming potential, ozone depletion, photochemical oxidation, acidification, eutrophication, and non-renewable energies. The geographical boundary of the study performed is within the typical used production processes and waste management within the European Union. And the study assesses the potential environmental impacts for the entire life cycle of each packaging system, often referred to as the cradle-to-grave approach. This all means that the packaging systems included all stages from the extraction of raw material to the final processing of the waste. And the evaluated waste management processes considered were disposal, recycling, and incineration. The system boundary of the study included the following stages of the life cycle. Production of primary packaging, including bottles, aluminum sheets, PET bottles, aluminum and polymer caps, craft paper and polypropylene labels, manufacture of secondary packaging materials, including corrugated board, craft paper, low-density polyethylene, and wooden pallets. Then waste management, in which the phases of recycling and waste disposal were considered, and then transport of raw materials, packaging material, and transport of beverage to the retailer along the life cycle. When we do all this analysis, it is important to distinguish between the packaging and the product that the packaging includes. In this analysis, the production of the product itself, that is beverages, were not included in the analysis, and this in turn means that the process of filling of beverages has not been studied either. The resources which were needed to perform these studies were the following. Data have been sourced from EcoInvent 3.2 and ILCD databases, as well as beverage manufacturers and literature. Then Open LCA software tool have been used for LCA modeling. The environmental impacts have been estimated accordingly to the CML 2001 method, and the study has been carried out following the ISO 14040 through 14044 life cycle assessment methodology. In this example of good practice, the effects of 3 packaging systems for the distribution of 1,000 liters of filled beverages, used cans, bottles, and bottles with a single 0.5 liter filled unit were evaluated. And the study shows that the production phase is the one that contributes the most to the overall environmental impacts of the global warming potential, that is around 90%. So it is necessary to pay the most attention to this phase and plan packaging in accordance with eco-design guidelines. And the main factors of this result are the type and amount of material used. There is a likely link between bottle weight and environmental impact. However, this relation is not true for aluminum cans, which are the lightest in terms of weight, but still show a greater environmental impact than PET bottles. It should be also noted that the single-use system has been assessed as one of the most common practices in the world. If the returnable bottle system were taken into account, the bottles would probably show lower environmental impacts, but the returnable bottle system should take into account additional bottle cleaning processes, transport, and other activities. The performance analysis shows that PET bottles are the least stressful among the evaluated systems, followed by aluminum cans and finally non-returnable bottles. Also, it can be observed that the end of life and transport phases affect the final values of the indicators less than expected. The life cycle inventory results were transformed into the parameters describing potential environmental impacts. And you can see on this diagram that the bottle production contributes most to impacts in almost all of the impact categories assessed, except in the ozone depletion category, where can production has a greater impact. This is due to the large mass of the bottles and the energy-intensive process of maintaining the high temperature required in the ovens. Bauxite used as a source of canned aluminum is a major source of the ozone depletion indicator. PET bottles show the lowest environmental impact in all categories. Their smaller influences can be attributed to the smaller influences of material and manufacturing and their mass. This also reduces the effects of end-of-life transport and disposal. Based on these results, it can be concluded that the process of making glass bottles has the greatest impact on the environment, as it contributes the most to almost all categories of environmental impacts. They are followed by the production of aluminum cans. Here the results are shown regarding different contributions of individual process phases to the global warming potential. And the individual phases are divided into the production of packaging, stoppers, secondary packaging, labels, transport, and waste management. It can be seen that the extraction of raw materials and their processing into primary packaging contributes most to the environmental profile of beverage packaging systems. It follows further that in the environmental planning of packaging, great attention must be paid to the choice of the packaging material. The production of secondary packaging is also important, and it can be observed that the end of life and the transport phase affect the final values of the indicators less than would be expected. Regarding the challenges, I can report that the following were excluded from the system boundaries due to the lack of data: ink use and printing process, as well as impacts in the home use phase and losses through the supply chain. Furthermore, the following activities were excluded from the system boundary, which was also due to the lack of data, such as production and packaging of beverages and their ingredients, mass flow contributing less than 1% to total mass flows, and transportation of consumers to buy a drink and any storage at the consumer. Therefore, lack of above described data has presented challenges to fully perform the presented study. This good practice demonstrates a good example how the principles of LCA methodologies can be implemented regarding an impact of drink packaging on the environment. Therefore, by following the outcome of this research, the public authorities could encourage companies and citizens of requesting from them to preferentially use environmentally friendly PET bottles, which would in turn minimize the environmental burden. In the research cooperation of the Faculty of Chemistry and Chemical Engineering at the University of Maribor with Slovenian companies, an increasing interest was noticed in conducting a life cycle assessment of a selected product or the entire company. Finally, the value of the contribution was not only in the obtained results of the analysis, but also to contribute supporting information for easier and more intensive use of LCA analysis. And I believe that this will provide companies with an instrument to support packaging policy decisions and make it easier to choose between different packaging options with comparable properties. So this brought me to the end of this presentation, and I thank you for your kind attention.
So thank you, Albin. That was a very nice presentation again, and very clear one. And before our discussion session, so we will have one presentation more, and this comes from Poland. So Adam, you are there? Yes?
Hello, can you hear me well?
Okay, yes. Yeah. Hope you are doing well as well. So nice to see you. And Adam's presentation is about redistribution of charges for environmental pollution into pro-environmental investments. So please go ahead.
Okay. Can you hear the slides here?
Yes.
Okay. So, hello, my name is Adam Szymanski from Lodzkie Region, Poland. As you see, I'm broadcasting from my kitchen, from my private gallery, art gallery. Today, I would like to present you a good practice connected with redistribution of charges for environmental pollution into pro-environmental investments. In other words, using taxes solutions and their advantages in waste management. So, the cycle looks like this. On the slide, you can see the cash flow, and on the other side, turning carbon-based technologies into green technologies. In those whole process, three public institutions are involved, but the main institution in charge in the regional context is the Regional Fund for Environmental Protection and Water Management located in Lodzkie Region. But before I shortly describe you how it works, please let me say a few words of introduction and problems we faced. First of all, the LCA concept is not implemented as obligatory in Polish legal system. Implementation by public entities is very limited to and difficult to identify. First of all, the LCA, that's why we could not indicate a simple or obvious LCA approach in our good practice. If you are focused on searching for this, you won't find it in this straight line. We have looked in the issue from a broader perspective. In fact, we show a kind of organization, LCA mechanism, which influence the policy of rational resources management or waste management in the region. Secondly, maybe this what we are going to present for some may not seem revealing and news for them, because in all the countries redistribution function one or the other way, but it's necessary to remember that the public institution don't do experiments, social experiments. They usually implement safe solutions that have already proven themselves in other sectors. For example, for science, NGOs, etc. So often these are not great discoveries, but they work, and you will find out how it works. Next slide. How it works. As I said, good practice refers to public institution, and it concerns the regional redistribution of funds from environmental fees obtained from entities that, using the environment, meaning generating some negative impacts, emissions, etc. And investing these funds into pro-ecological projects. Sometimes they are hard, they are investments, sometimes they are more soft, like educational projects. The procedure looks as it follows. First step is the collection of environmental fees by the Lodzkie Regions, so it's kind of my institution. In fact, it is the Marshal's Office Environment Department. Fees from these entities that pollute the environment. This is possible on the basis of the National Environmental Protection Law. It's very important that it is based on the Environmental Protection Law. In the next step, Lodzkie transferred this money to the National Fund for Environmental Protection. So the cash flow goes to a central level. And the National Fund makes environmental analysis and estimates current needs, and then distributes money to regional funds, which is several 16 each one for one voivodeship. So voivodeship is the Polish regions. One of them is the Regional Fund for Environmental Protection in Lodzkie Region. The last stage is the final allocation of money by this regional fund in Lodzkie. This is happening on the basis of analysis of negative emissions and environmental risks. Regional funds allocates funds in the region using LCA or LCC or equivalent methodologies and invests them in green technologies and pro-ecological installations. Allocations meaning that the grants, subsidies or preferential laws for green investments. Next slide. Investments. Areas that are covered in this way are mainly air protection, protection of water resources, waste management, and also waste of disposal and reclamation. As I said, also soft green educational projects for schools, etc. Final beneficiaries of this practice are both public and private entities and individuals. Referring to that, what I said, regional funds allocates funds in the region using LCC, LCA, or equivalent methodologies. I would like to add that what I say in the beginning, I would like to add that most pro-environmental investments in Poland should have the requirement of environmental impact assessment. And this methodology is a tool. Sometimes on some levels are related to LCA or LCC. Sometimes it can be more challenges than LCA or LCC. In fact, in some respect, it is more demanding and comprehensive. It includes some more features. The impact of the project of the environment, including human health, living conditions, material goods, even the historical monuments or historical heritages, and the availability of minerals and resources. So it is used at this stage of the process. Coming back to the main point, the process described in the good practice started in 2001 and still is ongoing. It is carried out in annual budget cycles, so year to year. Next slide. The scale. The required resources are funds collected by Marshal's Office of the Lodzkie Regions from environmental fees. in last year, it was approximately 35 million euros. This sum has been invested by regional funds for environmental protection in Łódź through loans, through preferential loans or grants. In numerous green investments you can see on this slide. Sorry. Okay. What are the results? Does it have potential? We think it does have potential. First of all, it has awareness rising effects in the society among entrepreneurs and other key actors. Every investment has to be an information board with our regional funds or logo and some investment, just like they did in the process of investment in the EU donations or grants. This practice supports the transformation from traditional technologies into pro-environmental investments. For example, our region is based mainly on coal energy. One of the biggest coal-fueled energy plants in Europe is in Bełchatów in Lodzkie Region. And investing in green technologies saves resources, have a direct impact on changing this process, and indirectly also on water resources, because as you know, coal mines generate post-mine waters problems and hydrological problems in our region. The scale of the reinvested money I mentioned, the 35 million euros allows to have a real impact, a positive impact on the environment. And also this generates a positive impact on the local market, connected with ability to reach out for best technologies available. So this GP is of a national character, of a central collector, and it works in several regions in Poland. This practice supports not only the implementation of modern ecological technologies, but also the use of various analytical tools, such as calculations based on LCA related tools. This application is possible whenever permitted by the national law. So if you need any further information, I would be happy to give you more information. Ladies and gentlemen, thank you for your attention, and have a fruitful discussion on this subject. Thank you for the presentation, and I'm looking forward to learn something more. Thank you.
Thank you, Adam. That was nice. I'm very glad that you all speakers have kept the time very nicely. And now it's time. We can everybody can now ask questions from the force regarding to first 4 presentations. So please you can open the microphones, and if you have a camera, so you may switch it on, and we can share some ideas together concerning these 4 presentations now. So and then later we might have able to have a short break if no questions are something that we should discuss more, but yes, please.
Yes, good morning, Pekka. Good morning, you all.
Oh, yes. Hi, Paolo.
I would like to really thank for the presentations. They were very interesting. And I have a specific question here for the Lombardy case about the construction demolition waste. I found it very interesting and very well fitting with the project, and hopefully also a source of inspiration for further activities in the project and to try to maybe transfer the practice in the action plans of another region involved in the project. Yeah, my question is if you think that since the renovation wave, it's very much put as a priority in the Green Deal, and also it's linked to the recovery plan. If you think that maybe next year's will be an opportunity to further develop your work when it comes to construction demolition waste, since I think that there will be a boost in the construction sector due to the renovation wave. So in my perspective, could be even more interesting to look at your result of your project and to support the idea to recycle construction demolition waste and maybe put in some minimum recycled content requirements in at least in public construction projects.
Well, yeah, yes. In fact, we are doing this PhD. So the first step was the environmental evaluation, so the life cycle assessment. In that case, we analyzed only the waste management system, but then we realized that it was also important to include the activities that produce the waste, because according to the different ways of demolition, but obviously also according to the different kind of buildings, we have a different waste. So we cannot evaluate just the waste management system, but to improve it, we need also to understand the step, the activity that creates, that generates this waste. So this is why now in the life cycle costing, we have included also the demolition step. And then, well, the PhD will last for 3 years. Now we are at the end of the first year. So the idea is, if it is possible, also to update the LCA study, because the LCA study was based on data of the 2014. So maybe we can update the LCA study and link it with the life cycle costing evaluation. This is our idea. And yes, I know that there is a big, there are many initiatives also at the European level on the construction and demolition waste, but I think that it is a good point, because the amount of construction and demolition waste is really big, very it is the construction and demolition waste is much more than the municipal waste. So it's important to find a good way of manage it. And also, if we are really able to recycle this waste, we can save many natural resources and all the problems associated with the quarries activities. So the land use, and so I think that it is an important topic.
Thank you very much.
Pekka, can I make a comment?
Sure. Fritz, please.
Okay, I have 2 comments. First one is a response to Adam's presentation on environmental fees, which at the moment I don't have any problems with that. But Adam, you made the comment that LCA is not compulsory, is not a legal requirement in Poland. I just want to make the point that we need to see LCA not as a legal requirement, but as a process optimization tool. LCA allows you to achieve greater efficiency and greater cost savings from the beginning. So we should not sell it as a negative instrument. We should sell it as a process improvement scheme. And after that, you may get a better reception from people with whom we're talking, particularly municipalities, but especially companies, to say, look at your process in more detail. You will find savings there. and you will find possibilities for improvement. So I think it's a very important point to put a positive spin on LCA methodologies, also for the companies. The second point is I was really happy to see some of the slides of Lucia that touched on the idea of keeping waste clean. For those of us who have a scientific background, we've heard of the second law of thermodynamics. It's a one-way process. Once we mix things, it's hard to unmix them afterwards. Many waste streams already start out clean, and then we throw everything in the same bin. And then it becomes dirty. And then somewhere we have to spend money and time to clean it up again and separate from the garbage the valuable components in there. So the idea of source separation, keeping waste clean in the first place, is in very many cases, it's the key to effective waste management. And it's the key to effective waste management systems. So keep it clean and it will be more effective. The only other thing I could add at this stage, I think nearly everyone touched on it, the issue of regional data. And I think we're all facing the same same challenge, I'm sorry, that there isn't a sufficient local database to make locally based decisions as cleanly and neatly as we would like to. So one of the things I think this is leading to is that we all need to be ambassadors to the region to say, start collecting regional data to add to what the country already provides as national data. And I think this is a discussion topic that we should take up sometime. Thanks.
Thank you, Fritz. Very important points.
I would like to say that I completely agree with Fritz on that point, but you know, my reflection is that in our region, in our country, the LCA comes from the market, especially from big exporters such as Atlas or Isodom. This one is connected with requirements on other markets. So I hope that the requirements taken from the market will influence our central and regional institutions. That's all I want to say. I completely agree with Fritz on that point. Thank you.
Just a brief reply to Adam. I think you're right that there's a problem selling LCA at the moment. There's a low level of consciousness of what it can do. And what we need is some good case studies. The whole cleaner production program within the UN and elsewhere started with a number of very revealing and very interesting case studies. And then it's a question of ventilating and marketing the case studies as examples of what can be achieved. And then little by little it will pick up. But you're right, it's at a low base, but we need to help it improve. We need to help it get to a higher level. And I'm really quite encouraged by the number of LCA examples that are coming through in the good practice examples, including, I might say, life cycle costing, which is underused. Let me just add one extra thing while I have the screen. It'll save me from saying it later. One of the things I'm surprised about is the focus on LCA is very good. But one of the things I'm surprised about, particularly in a thematic workshop which is dealing with waste management, there was almost no mention of materials flow analysis. And for good waste management, you need to know how much waste there is, where it's coming from, and where it's going. MFA is a tool for doing that. And yet, there's even less consciousness of the value of MFA than for LCA. And I think we all together need to change that. And so materials flow analysis is a very powerful tool for improving waste management systems. And I will show a slide of that in a little bit later. But I must say, there's a big opportunity to hook into this and say, if you want to improve waste management, you need better knowledge of where the waste is coming from and going to. MFA will do that for you. Thanks.
Yes, the MFA is the first step of an LCA, I think. for the waste management system.
Yes, I'm sure you did a sort of in-kind MFA at the beginning of your study, but you didn't mention it. And I think in your next presentation, maybe you'd make it a little bit clearer, and that'll help other people understand that it's an important first step.
Okay.
Okay, do we have still other questions at this point? Yes, Megan, please.
Yes, hi, thank you. I had a quick question for Elsa. A number of years ago, we were looking at using vineyard waste to produce energy using gasification. And the concern by the machine manufacturer of the gasifier was that the sulfur content was too high for the machine and that it would end up being corrosive. And so they suggested we not use the vineyard waste. So I'm curious if sulfur has been an issue for Elsa, and if so, how they got around that. Thank you.
Yeah, thank you so much for your question. Unfortunately, I cannot give you a straight answer, but nevertheless, I can answer that. Well, as the material has still to be processed, that kind of problems were overcome. So perhaps in the specific machinery that you were mentioning as you were talking about gasification, it would be harder. But here we have all a process of transforming the residue into pellets and eco pellets. So that was overcome in the process.
Hecco, I'm just wondering if you're in a position to reply also to Megan's question, because I noticed in your good practice on the biogas comparison, there was a comment, a footnote, to say that sulfur compounds were a problem, one of the limits to it. Are you close enough to that study to be able to answer the question? I myself was wondering where the sulfur was coming from.
No,
okay.
I'm not able. Maybe we can discuss with Tuuli as she is presenting the study later from the biogas. Right. So we can continue after in the later sessions.
Let's do that. It's
okay.
A small point.
Okay, thank you. It seems I'm looking our schedule, and I think we won't take any special break at this point, but going forward to the second part, if it's okay for everybody. And in this second session, second part, we will have presentations from Spain, Lithuania, Finland, and then have a summary of the other good practices that have appeared now for this team. Presentation by Fritz Balkau, and then at the end of the webinar today is a presentation by Auli Westerholm from Fortum Waste Solutions as a case about plastics. But before that, so we will start with the presentations of Maite. Maite is online. So, hello.
Hi.
Maite, nice to see you. And you will be presenting carbon footprint of the food bank of Navarre. So please go ahead.
Yes, let me see if you can see my screen.
Yes, very well.
So thank you, Pekka, and thank you very much to all for the very nice discussions. Well, my name is Maite Aldaya, and I am a researcher at the Institute for Innovation and Sustainable Development in the food chain of the Public University of Navarre here in the north of Spain. Well, and where we carried out this study on the carbon footprint of the activities of the Food Bank of Navarre. But before starting, I would like to thank the government of Navarre and the workshop organizers, of course, for the invitation to present this case study. I would also like to take the opportunity to thank the Food Bank of Navarre and those institutions that finance my talent attraction for research grant, which are Fundación Caja Navarra and Obra Social La Caixa. And I would also like to thank the people who contributed to the report, among others, Beatriz Soret, Alejandra Armijos, and Susana Aldaz, who is now, I think, listening the presentation here. And of course, to all of you attending this session. Well, in the presentation today, I will summarize the main results of a longer report of more than 50 pages that you can find in the website of the Food Bank of Navarre. The link is available at the bottom of the slide. The aim of this study was to promote the reduction of greenhouse gas emissions using the carbon footprint indicator and show the environmental benefits associated with reducing food waste, as we will see. In the first part of the presentation, we will review very quickly the context, concepts, and methodology. You're a bit technical, but I will go quickly through it. Second, we will look at the main results of the carbon footprint of the activities of the Food Bank of Navarre. We will then analyze the greenhouse gas emissions in a hypothetical scenario without the existence of the food bank. We will see the emissions associated to the food waste management systems and the additional food production, as I will explain. But perhaps the most interesting part of the study is the comparison of the scenario of the emissions with and without the existence of the food bank. And in this case, we will see very clearly the relevance of reducing food waste in terms of saving greenhouse gas emissions. Well, without further delay, let's move to the context, concepts, and methodology. Well, as we all know, currently, globally, about 1/3 of the food produced for human consumption is lost or wasted. In this context, the Food Bank of Navarre is a foundation of 25 years of experience that plays a key role in the rescue of food that would otherwise be wasted, as well as in the intermediation, so that the food reaches the most disadvantaged people in the community, of course, free of charge. As regards the concepts and methodology, we use the carbon footprint of an organization to measure the total greenhouse gas emissions caused directly or indirectly by the food bank. Data along the whole report, as you will see, will be expressed as tons of CO2 equivalent. There are different greenhouse gases, such as the CO2, methane, or nitrous oxide, among others, but the CO2 is the greenhouse gas with the greatest influence on global warming. That is why greenhouse gas emissions are measured relative to this gas. As regards the methodology, we follow the guidelines of the Spanish Ministry for Ecological Transition and Demographic Challenge, as well as international standards, including the Greenhouse Gas Protocol, the ISO 14064, or the IPCC guidelines. We applied a very simple equation to obtain the emission estimate by multiplying the activity data by the emission factor for that particular activity. The activity data is the data on the magnitude of a human activity resulting in emissions, such as, well, for instance, kilowatts hour for electricity. A focal point at the food bank provided us the activity data, including the consumption invoices, vehicle mileage, food records, and the data from the interviews related to volunteer transport. The emission factor is a coefficient that quantifies the emissions of a gas per unit of activity. It is the intensity of the emissions. And the data on the emission factors were obtained by the Spanish Ministry, the Catalan Office for Climate Change, the French Agency for Environment and Energy Management, as we didn't have the data for Spain, as we will see, and the Commonwealth of the Pamplona region, who estimates its carbon footprint every year. A comparison is made of the scenario with and without the action of the food bank. In the scenario with the existence of the Food Bank of Navarre, we accounted for the emissions related to transport of food, transport of volunteers, electricity, gas boilers, and other goods and services, such as the water service, cardboard, or wooden pallets. In the scenario without the existence of the food bank, the food that is generally rescued by the food bank, this is the food that is poorly packaged or close to the expiration date, will go to waste. So in this scenario, without the existence of the food bank, we have two components, or we consider it two components. First, the food waste will be disposed in landfills or treated for reuse or recycling processes that will generate greenhouse gas emissions. We did a very detailed analysis here with the support of Susan Aldaya. Second, an additional food production would be needed to produce food that in this scenario is wasted, which will also generate greenhouse gas emissions. So we considered these two factors in the scenario without the food bank. We estimated at the end the annual carbon balance of the food bank, which is estimated as the emissions generated by the food bank minus the emissions that would be avoided by the use of food that would otherwise be wasted. Let's have a look at the main results of the carbon footprint of the activities of the Food Bank of Navarre. The total emissions by the food bank were 147 tons of CO2 equivalent in the year 2018 and 148 tons of CO2 equivalent in 2019. These figures are similar to the emissions produced by a round-trip flight from Madrid to New York. So you can see that the emissions of the food bank are not so high, but just the same as a flight from Madrid to New York. The graph on the left represents a summary of the greenhouse gas emissions related to the food bank activities by category. As you can see, the logistics, the other indirect emissions, that is the transport of goods, the transport of people, together with the consumption of goods and services related to the service of water, cardboard or wooden pallets, is the main greenhouse gas emitter. The three of them account for 82% of the total greenhouse gas emissions. So in the carbon reduction plan, we made a proposal to use more frequently the public transport and also to implement renewable electricity. More details can be found in the main report. I will not go into that now. So we can see that the rest of the emissions by the food bank are lower, like the stationary combustion or the vehicle movement of that belong to the food bank, or the indirect emissions from electricity are much lower than the transport. As regards the emissions in a hypothetical scenario without the existence of the food bank, we mentioned that there are two elements: the emissions associated with the additional food production and the emissions related to the waste management activities, mostly organic waste management activities. We will have a look at both of them. Let's start from the production of food. The greenhouse gas emissions in this hypothetical scenario without the food bank related to the additional food production will amount to 4,272 tons of CO2 equivalent in 2018 and 3,914 tons of CO2 equivalent in 2019. So the numbers are much higher than the carbon footprint of the food bank we have just seen. As you will see, the emissions are a bit higher in 2018 than in 2019. This is because the quantity of food managed in 2018 was larger than in 2019, about 300 tons higher. As regards the kind of food managed by the food bank, the largest emissions were associated with the dairy products, more than 20% of the emissions of the total additional food production. This is because of the large number of dairy products managed by the food bank, particularly yogurts, and because the dairy products also have large emission factors. Vegetables and legumes, prepared meals, and fruits also presented more than 10% of the emissions, each of them. Perhaps one of the main challenges that Fritz has also mentioned was to found data, local data on the emission factors associated to food production. So we couldn't find them for Spain, and we finally used the emission factors from the French Agency for Environment and Energy Management, the ADEME database, which presents an uncertainty of 30%. This was on the food production side. Let's have a look now to the waste management. The emissions associated to waste management would have been 443 tons of CO2 equivalent in 2018 and 390 CO2 equivalent in 2019 in this scenario without the existence of the food bank. Again, the emissions were higher in 2018 because the quantity of food managed was larger in that year, in 2018, compared to 2019. The emissions were analyzed in detail for the different waste management systems for the regions of Pamplona, rest of Navarre, and rest of Spain. From the different treatments analyzed, the landfill would represent 85% of the total emissions generated by waste management. This is because in the landfill anaerobic conditions, the methane gas is produced, which is a strong greenhouse gas. The rest of the treatments produced less greenhouse gases. For example, composting amounted to 7%, biomethanization 5%, paper and cardboard treatment 2%, light packaging 1%, and glass treatment 0.1% of the total emissions associated with waste management. Well, finally, let's have a look at the annual carbon balance, that is the comparison of the scenario with and without the existence of the food bank. The greenhouse gas emissions generated by the activities of the Food Bank of Navarre were notably lower than those in a potential scenario without the existence of the food bank. With the existence of the food bank, the emissions were, as we have seen, 147 and 148 for 2018-2019 respectively. Whereas without the existence of the food bank, the emissions associated to waste management and the additional food production amounted to more than 4,300 tons of CO2 equivalent in both years, so are much higher. Consequently, the activity of the Food Bank of Navarre prevented the emissions of 4,568 and 4,157 tons of CO2 equivalent in 2018 and 2019 respectively, contributing to climate change mitigation in line with the climate change processes and initiatives at the regional, national and international levels, such as the regional climate change strategy, the Spanish circular economy strategy, the European Green Deal, Paris Agreement, and agenda for sustainable 2030 agenda for sustainable development. In summary, the carbon footprint of the Food Bank of Navarre was 147 tons of CO2 equivalent in 2018 and 148 tons of CO2 equivalent in 2019, mostly associated with the transport of food and volunteers. In both 2018 and 2019, the emissions avoided by the use of food, which would otherwise be wasted, are notably higher than those generated by the activities of the food bank. Consequently, the activity of the Food Bank of Navarre prevented the emissions of 4,568 and 4,157 tons of CO2 in 2018 and 2019. These results highlight the importance, not only social, but also environmental, of the Food Bank of Navarre, since it prevents a large amount of greenhouse gases from being emitted into the atmosphere. So this was my last slide. Thank you very much for your attention. I don't know if there is time for questions now or later, but if you want to contact me later on by email or whatever, I will be happy to answer to you. Thank you.
Thank you, Maite. That was a very nice presentation. I hope that can you stay online during
Yeah, I will.
Question session, so it's better than, and we should there was some questions, so I think that we will continue to Kaunas. So Jolanta, you are online there, so please, we will right away continue.
Hello everybody. So I will try to share my screen. Okay. Can you see the screen?
Yes, very well. Yes.
Thank you very much. So I will present actually the research of my colleague from the Kaunas Institute, from the Kaunas University of Technology Institute of Environmental Engineering. And I'm Jolanta Dvarioniene, I'm representing this institution. And also, as I said before, I will talk about the application of life cycle assessment in optimization municipal waste management system. The research work was done by PhD student that time. Now she's defended her thesis, and now she's working at IVL in Sweden as a waste researcher. So this good practice based on PhD thesis, integrated municipal waste management system decision support model. And the aim of this research work was to create a better understanding of decision support mechanism in optimizing the municipal waste management systems from the environmental and economic point of view. An integrated life model for municipal waste management was created and tested in an empiric context of Alytus region, one of the region of Lithuania, in order to optimize regional waste management strategies. So the study uses life cycle assessment methodology to build a model and test different waste management scenarios in order to see whether the waste management hierarchy is influenced by regional conditions. And as I said before, this model was created using the life cycle approach, life cycle thinking, and using life cycle assessment. And the discussion is built around a case study in Lithuania Alytus region, where several waste management scenarios have been analyzed and compared in the LCA framework. The modeling was assisted by LCA software tool. We call it BAMS, Waste Management Planning System, which was designed by Swedish Environmental Research Institute, tested and calibrated in collaboration with the Institute of Environmental Engineering at our university and with Stockholm Environment Institute CEI in Estonia. And I don't want to go deeper to the details of the model, but also I would like to mention that conceptual model was also, in the conceptual model was also the LCC, life cycle costing part, was applied by dividing the waste flow into 5 fractions: mixed waste, biodegradable fraction, recyclables, glass, paper, metals and plastic, hazardous waste, and rest fraction. And of course, the model was integrated model suggests performing and sensitivity analysis prior to taking concrete decisions, determining input values more carefully for the parameters that are influencing the end results of the study. So, as I said before, the Alytus region is in the south of Lithuania. The total population is 216 approximately thousand of inhabitants, and mostly the population lives in single family houses, And of course, there are a lot of blocks of flats. And Alytus region is one of 10 administrative units in country, with about half of the population residing in cities and the rest in rural areas and small towns. The region represents a typical setting in Lithuania where half of population lives in individual houses. And both Alytus town and the villages have typical features of a non-metropolitan part of the country and represent about the half country's population. And as I have mentioned before, there were created and analyzed different scenarios of waste management. And you can see from the treatment of methods included in the scenarios was individual composting, separate collection of materials and recycling, separate collection of bio-waste and composting, landfilling of mixed waste, mechanical biological treatment, biostabilization, incineration, landfilling, incineration of mixed waste, and these were dedicated, these treatment methods and in scenarios were dedicated for 5 scenarios, and we call those 1, 2, 3, 5, and 4 and 5 scenarios with different reference compared with reference scenario. And these scenarios, as you see, the scenario 1, the reference scenario mostly was about the landfilling. Most of municipal solid waste is landfill. And for the second and third and fourth and fifth scenario were selected different treatment and methods. For scenario 2 was recycling, composting, and landfilling, separate collections of secondary material and recycling, separate collection of biodegradable waste and composting, and landfilling of remaining mixed waste. The third scenario included recycling, composting, mechanical biological treatment, and incineration. And the fourth scenario with the recycling and incineration. And the fifth scenario, recycling, mechanical biological treatment, and incineration. And as I said before, we did the life cycle assessment, and we compared different categories, but I will present only few categories with the results of different scenarios analyzed and used. And you can see from the right side diagram how and which waste are most important in the region. And you see that 36% of bio-waste was generated and produced. Then we have 15% paper, 2% metal, 8% glass, 12% with plastic. And then bulky waste, 13%, hazardous waste, and others, some different waste. And from the results for impact category global warming, obviously, without any researches, we can see that the landfilling is the most contributing to the environment with the global warming as a scenario. But with other scenarios show that, for example, composting and incineration, for example, the maximum rate of incineration represented by scenario 4 appears to be the technology that is most efficient in minimizing greenhouse gas emissions, though the substituted electricity and its respective environmental impacts were calculated taking in the average Lithuanian electricity mix. And most positive effect of recycling is seen in all relevant scenarios, especially in the acidification category, where the net effect is an ecological benefit. The most likely explanation is that the production of materials from virgin material resources requires considerable amounts of energy based on dirty fuels such as coal or crude oil. And of course, the research work was done almost 10 years ago, and nowadays the mix of energy in Lithuania was changed, and our plans are really very well combined with using renewable energy sources. Would be nice to recalculate or make additional researches using the different types of energy mix. And in conclusion, application of LCA approach in this case study has shown that landfilling gives the worst environmental results compared to the other waste management options. When it comes to biodegradable waste fraction, aerobic composting is not a better option compared to incineration with energy recovery in all impact categories. This indicates that under defined circumstances, the waste management hierarchy should be applied flexibly. The use of an LCA approach in modeling the waste management systems provides also a good opportunity to map the entire system in its entirety and makes it possible to assess the data quality requirements. Therefore, LCA models in waste management area should be complemented with other decision-making tools such as life cycle costing or social life cycle assessment. And there are some references from the research work done. And of course, there are contacts of Jurate, my colleague, and she was also, she can't participate because she had other duties with other events, but she is free to collaborate, and if there are some interest, she would like to know about that. And really, the institute is looking for the projects and for the evaluation of regions using WAMS, waste management software developed and by research group together with other partners from Kaunas University and CE from Estonia. So thank you very much. If you have some questions, I will try to answer, or I will also communicate this to the main author of this good practice.
Thank you, Jolanta, so much. This presentation again, and a good view from Lithuanian situation. And so we will have still now one presentation. It comes from quite close to us. So Tuuli Myllymaa, Tuuli, you are online. Tuuli is going to present about processing alternatives of biodegradable waste, anaerobic digestion, energy and biofuels. So please Tuuli, the floor is yours.
Okay, thank you, Pekka, and I hope you can hear me and you can see me too. Maybe?
Yes, we can. Yes.
Okay, let's see if I can share my screen, and just a moment.
Yes, very well.
Okay, and then some. Okay, maybe you can now see my slides.
It's on the presentation mode, so.
Okay, let's. Better?
Yes, this is better.
Okay, yes, great. Okay, so my name is Tuuli Myllymaa. Nice to meet you all here in virtual seminar. I'm coming from the Finnish Environment Institute, and we have been studying these LCAs for waste management some years, and Pekka and Elsa asked us to present these alternatives that we have been studying for some years ago. And nice to be here, and it has been nice to hear your studies too. And then what it's all about. Here you can see the picture of our alternatives that we have been comparing in the previous study. And in this study, we tried to find out the sustainability differences of these three alternatives. And the first alternative is the what is the system how is it surviving when this bio-waste, which is in mixed waste, is burned. The second alternative is that this bio-waste is transferred to biogas and digested. And the third one is making the biofuel. And as you can see, there are some system description what has been taken into account. Of course, everything is tried to be included into this, and all the transportation and all the processes and all the energy use. And the products from each of these alternatives are, in the first scenario, is the energy, which is produced into heat and electricity. As you know, here in Finland, we need quite much heating during winter time. For example, right now there is some +degrees here, but we have quite cold winters, so we need both electricity and heat. And in that biogas and digested alternative, the end products are also the electricity and heat, and the digestate is another product. And in the third one, there is an example of one scenario in Finland, one actual company which is producing biofuel. So these are actually all representing regional data. So we have been trying to use as local data as possible. And in that biofuel process, they produce the biofuel, but they also process and produce some biogas and therefore electricity and heat. And also digestate is produced when producing biofuel. And there in the down part of this slide, you can see those avoided impacts. So what are the benefits from doing all these operations? And the electricity and heat is modeled to represent and avoid the regional energy that is used and produced. And in electricity case, the assumption is water and coal-based energy, which is very typical. 50-50 in Finland is the typical share. And in the heat case, it is assumed to replace wood and oil origin of heat. And for the digestate, in Finland, biowaste is produced by source separation. So each household is collecting all the waste fractions separately, and one fraction is biowaste. And that means that we have quite good quality biowaste, and it can be used as soil conditioner afterwards. So it can also avoid some fertilizer use because of the nutrients that are included in that mold, and that's why there is some avoided impacts from fertilizer production. And in that last option, the biofuel production, the biofuel is used in vehicles, and therefore it's avoiding then the gasoline production and use. And electricity and heat and fertilizer are like in that previous cases. And then what does it look like? I have some results here. If I can, yes, I could change the slide. So the LCA results show here. You can see the results from the climate change categories, and you can see each of these three alternatives in these bars, and you can see that the direct emissions are smallest in the biogas production alternative. And then in that avoided emission part, you can see that there are some differences in that part too. There are a little bit more avoided emissions in the bioethanol case, but although there is a little bit more of those direct emissions too. So of course we are interested in to see what is the sum balance when these are taken both together. And I can see that, I can show that that slide next. Yes, great. So the sum balances show that in that climate impact category, there are some differences between those three alternatives, but as you can see, the differences are not that great. And if we take the uncertainty analysis, which are those narrow lines there, you can see that the differences are very, very minimum because they are quite in the same level each. But you can see some differences in acidification. So the burning of the bio-waste in the mixed waste is the worst one because it's producing some sulfurous. It's coming from the burning process. It was mentioned that sulfur before, so it's coming from that burning process. And so the biogas and bioethanol production are more sustainable in acidification effects. And we must also keep in mind that in those biogas and bioethanol production processes, they can save the material content of the waste also. So there is something to put into ground again. So it's not spread into the air, even though it's bio-based emissions, but anyway, we lose the material and it has the carbon content, which is adding the carbon dioxide concentration in the air, no matter what is the origin, actually. So I already mentioned that we have the source separation of the bio-waste, so that's why it can be utilized in green building. And I just added the mentioning there that we didn't compare the costs that are produced in these three alternatives. So I would assume that the bioethanol processing would be the most costly one, but as mentioned, we don't have that data. Okay, then I have some other things I was planning to tell you. So actually in Finland, the bio-waste processing with the biogas production is strongly supported by the Finnish environmental policy. So during years, we have quite much made different studies on LCAs on waste management, and they have been used in supporting the strategies, for example, National Waste Plan, and also in planning the legislation and taxation and so on. So when we saw the three results from these three alternatives, we could show that there are not very big differences when what comes to the environmental burden, and but there is also not big problems. For example, in the bioethanol case, but it was marketed very strongly some years ago, so it gave the picture that this is the most beneficial way of treating bio-waste, and the old ones are just poor ones. So we could show with these results that well, there might be some marketing and business ideas that are supporting those new ones, but in environmental perspectives, they are not very big differences there. So already before, we have done some LCA work for the Ministry of the Environment, and we have shown that the anaerobic digestion is much more better than composting, and also these are supporting those decisions that has been made. And the most currently that this data is from some days ago. In paper, I read that the Ministry of Economic Affairs and Employment is planning to ease the environmental permit processes, especially for establishing farm-scale biogas plants. So they are trying to support this biogas production in Finland, and also that small scale processing too. And there are very many good points in this biogas production. It brings both electricity and heat, and it can be used also as a vehicle fuel if you produce the biogas in regions, there is the network for example, the gas, or then you can also have the station only for selling that gas for example, for trash cars or private cars. So that's why I think this biogas production is a very good example on waste management, bio-waste management, and especially when connecting it to the source separation of the bio-waste, because then you can real life sell the digestate as a mold and use it for green building or like that. And yeah, and the several sizes is an option too. Yeah, so I think, yeah, that was the plan. What was I thought before that I could tell you. So we have published these LCAs before. Unfortunately, they are all in Finnish, but they have the summary in English. But this is linked to the report that includes this comparison, and then we have some other studies too. And we have, for example, studied wood processing with different alternatives, but we have some not that good experience on how to use these results in EU Commission discussions. So we got very good results, but then the answer from the EU was that even though these LCA studies are showing priority on some case, it's the recycling targets that are the key, and these are those targets that you must fulfill. So you can't use these LCA results when comparing what are the recycling targets and what are the national recycling amounts. So we can't use them, so that that's why we can't achieve the targets, because we can show these environmental balances. The answer was quite clear. So the targets are be set so that these must be fulfilled, and that's why this that one wasn't that good example. But this bio waste and maybe the biofuel also, I think they are quite good examples. Okay, thank you. I hope you have been hearing me all the time and seeing my slides, but thank you very much.
Thank you, Tuuli. Hopefully, I don't know if you can stay online for questions. I think at this point now we could have discussions about the first presentations about the Navarre food bank example, and then the Jolanta's presentation about optimization of municipal waste treatment systems, and then about this last Tuuli's presentations about anaerobic digestion and bio-waste treatment. So please go ahead and if you have any ideas, comments now. So just open the microphone and you may ask and send commentaries.
Hi, I would like to make a question to Jolanta.
Yes, please.
Yes, because I didn't understand if the region or the government used the results of the study in some way. So the actions after the study, if there are any.
Yes. Jolanta, good. Are you online? It appears that maybe she's not online.
Yeah.
Unfortunately, maybe if she comes later. Or could you, Lucia, write this your questions to the chat so that we.
Yeah, sure. Okay.
So that we don't forget that one, and Jolanta will see that later.
Okay, can I put a question or a point?
Yes, please. There is Jolanta already.
Jolanta, go ahead.
Okay. So, Jolanta, please.
I'm very, very sorry because I got a phone call I had to answer, so I didn't hear, but maybe it is related with the question to, I think, yes, to Maite. I wanted to ask regarding the avoided emissions in slide 15. She has mentioned. For me, was interesting to hear what were the avoided emissions.
This is for me. But I think you have, Jolanta, one question from Lucia, no?
Yes, maybe I can repeat the question.
I had myself, yes. Okay.
My question was about if there were any actions from the government or the region after the results of your study.
Yes, I can confirm this. And if you can go to the paper, scientific paper published in the Waste Management and Research, and there are also acknowledgement to regional waste regional authority, because we have several regions and each region has the authority for waste management. They are responsible for all the management of waste in the region. So with their help, it happens. Because maybe the second question could be why in other regions you hadn't such examples, because I would say that in some regions there are very active managers and they front runners always. For them it's always everything is interesting. International projects, experience from other countries, and they were the pioneers in Lithuania, and they were asking our institution for we had a long cooperation with them, and actually they did, and they initiated many things in their regions, like for bio-waste separation, for recycling, for second-hand goods system. So they really were involved and they used the data and they were co-operators in this research work.
Good, thanks.
You're welcome.
Thank you. So, but Jolanta, you had a question for Maite, I think.
Yes, I was listening to a presentation. Thank you very much. It's really very nice. And you know, I was surprised because the same we have the bank in Lithuania, food bank, and we received also request from them to calculate CO2 or yes, emissions. And for me, it was like, oh, this is like something similar what our colleagues or our customers they need. And for me was interesting regarding in the slide 15 you presented avoided emissions. So I just wanted to ask, but maybe I can ask after all, or we can discuss a little bit more deeply the good practices. Really very nice.
Of course, I have to tell you that this is not the first study on this, that there was previously a study from the food bank of Bordeaux in France, done by Veolia on this, and also from the food bank here in Spain of Cordoba, doing the same thing. So I can share all of them with you. But anyway, I will try to answer your question if you want. Now, quickly, I think it was this slide that you were mentioning, no?
Yes.
That here I talk about the avoided emissions. With this, I want to show, like in the scenario with the food bank, we have some emissions, no? The carbon footprint of the food bank of Navarre. scenario without the food bank that this is an hypothetical scenario, it's not real, but we calculated that if the food bank is not there, the food that was going to be used would go to waste. So what would be the emissions of this food waste treatment or in the landfills? So we included here those emissions, and also we calculated the new food that would need to be produced. And we did the estimations. To tell you the truth, it was a bit complicated to try to ask all these waste managers and companies to know which was the treatment. Thanks that I had the help of Susanna Aldaya, that they compile an inventory of these waste managers, and we knew where the food waste is going to and which kind of treatments, but it was a bit kind of complicated. But so we calculated that, and then we do the subtraction of the emissions with the food bank minus the emissions without the food bank. So this is what we call the avoided emissions, in a way that to show that the food bank would prevent these emissions.
Okay, thank you.
I don't know if that's clear.
I also thought about maybe not produced food or waste, something related, but thank you for your clarifications.
And we can, of course, talk later on if you want, or I can send you the examples of the food banks if you want.
Hello.
Yes, Raul.
Hello, my name is Raul. Yes, thank you, Maite. Very, very interesting presentation. We are working nowadays with food bank, and we are very interested in this issue. Only one question about the slide number 14. I don't understand. It's possible. It's a mistake for me. You said the emission 14. Please, one before. Yes, okay, thank you. Here, you say only MCP produce or contribute composting, and the other producers, other local entities don't produce composting, only contribute MCP to composting. Is true? Sorry, Maite, could you open the... Thank you.
Sorry, yeah. Now I think that I didn't switch it on. Anyway, so thank you for your question. It was complicated to obtain all this data, as you can see. So we got the data from the inventory of domestic and commercial resources in the case of Pamplona, Commonwealth.
Yes.
So we got that data from there. Then I got the data from the rest of Navarra for those organizations that provide the food to the food bank. Just focusing on those. We look at the waste managers, what they do, and that these are the results. So in this case, there were no other companies or waste managers related to companies which do the composting. But as mentioned, it was kind of complex to do this. And for the rest of Spain, I just got the data for the Catalan agency. I wrote all the provinces, the communities trying to get the data, but I just got the reply from the Catalan ones. So I assumed that the products originating in the rest of Spain were from Catalonia and from Navarra. So that was the data I have. So I couldn't reach more. Yeah.
Okay. Thank you, Maite. Thank you very much.
So, thank you.
Becca, can I make a final point?
Oh, sure. It's your presentations. Time for you as well, so you may continue.
I want to follow up on Maite's excellent presentation of the food bank. Congratulations for the initiative, and also a very nice presentation. But it reminded me of something that the UN is doing, which is called organizational life cycle assessment. When you look, Maite, at the impact that the food bank has against no food bank. It reminded me, I'm going to try to share the screen to show you. Can you see the screen?
Yes.
Okay, it's a process that they've developed to adapt the life cycle analysis, the LCA process, to organizations. Most of us are used to using LCA for products or for industrial processes, but you can also apply it to an organization. Now, what you've done with the food bank in Navarre is already a type of process of what we call organizational life cycle assessment. You focused on greenhouse gas, on carbon footprints, not on other issues. Nevertheless, the process is very similar. And I just want to draw attention for all of the partners and their stakeholders to the fact that to carry out an LCA of an organization can bring very valuable insights into how the organization itself can reduce its sustainability impact. Now, your excellent example has gone down that particular path to say, as an organization, what's our footprint? What's our impact? And how can we apply LCA to an organization? So I would encourage the partners to go more deeply into what you have done, but also in particular to look into this excellent publication by the UN, UNEP, and the Life Cycle Initiative on what we call OLCA, Organizational Life Cycle Assessment. It has a lot of value for organizations, in particular regional organizations. That's all I want to say at this stage. It's a bit of marketing, really.
So
Yeah,
thank you very much, Fritz. Yeah.
Yeah, where do I need to?
So there are more details on the and useful details in the report on the carbon footprint reduction plan and so on. But I couldn't include all of it in the presentation. So yeah, I agree with you that we should encourage this. Thank you.
Thank you. Now, Fritz, please continue. We have a bunch of plenty of other good practices that we were not able to present so thoroughly today, but Fritz has promised to summarize now for the other good practices of different regions. So please, Fritz, the floor is yours.
Thanks, Pekka. I seem to have lost the file that I wanted to share with you.
Take your time.
That's not that one. I apologize for disorganization. No, it's not that. Oh, I had it a moment ago and it's gone now. Bear with me just for one short moment. Well, while I'm looking for the slide that I'm looking for, just a moment.
Pekka, sorry, it's Paolo here from Interplus. Can I take the chance to ask 2 questions to decade, because I heard about composting turning out not the best scenario both in Lithuania and Finland. So I'm just wondering what are the impact categories that were taken into account to have such results.
Okay, Jolanta? Or...
Okay, I can
Tuuli?
answer to Paolo. Thank you for your question. Actually, for evaluation were selected 4 categories: global warming, acidification, eutrophication, and photooxidant. So these, according to the literature review, were selected for waste scenario evaluation using life cycle assessment. So if I answer to your question.
Yes, perfect. Thank you very much. I'm wondering if maybe land use or water consumption or other kind of impacts can maybe turn other
because those scenarios were, as I presented, 5 scenario or 4 scenarios with the reference scenario, where those scenarios were selected and also impact categories were, according to literature review, the most suitable formulation of different waste management scenarios evaluating using life cycle assessment. Those 4 categories were selected.
Okay, thank you very much.
Thank you.
Okay.
So Fritz,
I'm back online.
Yes, and please try to keep the time so that we can.
I will try to be very short.
At 1:30 to.
Okay. Can you
good.
see the screen, the table?
Thank you. Yes.
Okay. What I'm going to do is the group of good practices here that we have in grey, which were not able to be presented in detail because of the time shortage. I'm going to give an overview of what is inside these good practices and to pull the best parts out of them for sharing with the other partners. So if we look at it, we have a number of good practices on materials and waste management systems. This is quite important. It's not just about single products, but also waste management systems. We have Lithuania, Portugal, and Navarre. Navarre has 2 good examples of management systems that are based on some form of life cycle thinking or life cycle structure. Lithuania, we've just heard the excellent presentation from Jolanta. Portugal, from Elsa. But there's a particular one on demolition and construction waste, which is a very systematic approach to dealing with that at the regional level. Navarre, we had the good practice of using a local currency to arrange a waste management system at the local level, which was also, I thought, very novel and very worthwhile to study. And also the very good example from Maite on the food bank. So these are examples of good practices on constructing waste management systems that are based on some form of life cycle thinking, if not formal life cycle analysis, as was the case in Lithuania. We had a number of good practices that are using LCA for the comparison of waste policy options. Finland in particular had 2 good examples, one using biogas, which we've just heard, and the other one on the use of wood waste and what should be done with wood waste. And then we had policy options from Slovenia in the use of packaging. What are the pros and cons of certain types of packaging? And that was used a formal life cycle assessment. All 3 of these examples of LCA comparisons of waste policy options use formal LCA procedures, and the results, I think, show that the value of using an approach like that, despite some of the data limitations. The other example, or good practice examples that took my interest were using LCA and life cycle costing for processes in waste flow, and particularly the Lombardy example of construction waste. And the second example was optimizing electricity use and power use on construction sites, using life cycle costing to look at the cost of electricity in particular, and then saying where can we make economies and where will we be able to make environmental improvements. So the use of LCA and LCC for defining and studying processes is also very valuable, and we're pleased to have 2 examples. Thank you, Lombardy, for providing both of these examples, both of them in the construction sector. The other one, I've just snuck this one in, organizational LCA from Navarre. This is the example of the food bank. To use an LCA, in the case of Navarre, it was a carbon footprint calculation of the food bank to say, well, how can we look at the operation of a regional institution through the life cycle lens? So that was also a very good practice, which we hope can inspire others to follow the same way. There are a number of good practices on the LCA of products. Navarre and Slovenia in particular. Slovenia we've just mentioned, packaging. Navarre, we had the case of using paper-based soil covering rather than plastic-based covering for soil, avoids the use of plastic waste in the soil subsequently. Both of these are very well-known procedures for studying a product that has importance at the regional level. Two good examples there. Finally, the use of life cycle procedures, life cycle thinking for greenhouse gas footprints, carbon footprints, energy studies. As I said, that this is very important these days as we're going through scenarios of climate change reduction. Both Lombardy and Navarre touched on this, the use of life cycle procedures for studying footprints. I did add the use of environmental fees and credits used by two regions, Lodzkie and Navarre, use of innovative financial schemes to improve regional environments. Well done, both of those regions. So when we look at this, we see that the use of life cycle tools in the good practices that we have by the regional partners is largely focused on LCA, a little bit on life cycle costing, and a number of examples of carbon footprints. So these are certainly primary examples of use of life cycle methodologies. However, as I already foreshadowed in my response to Adam, what about MFA, materials flow analysis, and social LCA? These are both important issues for the region, and we haven't seen any use of that. And I would like to encourage you. This is an example of from the European Union of materials flow analysis of regional waste flows. And we can see on the left-hand side the sources of the waste. The colors represent the fate of the waste, and on the right is what actually happens. And this allows us to study the volumes, but also the flows, starting point and the end point. Very valuable technique when we're talking about waste management systems. Life cycle structure, I just want to finish off saying, well, there have been a number of examples of life cycle costing that have come through, particularly from Lombardy. Jolanta mentioned it also. What we need to do is focus life cycle costing also on what we call environmental life cycle costing, which is to cost out the externalities, environmental impacts, the environmental costs. This is the next step that we need to take when we look at good practices using life cycle costing. Finally, the reason I mentioned social performance is because nearly all of the good practices have made a big mention of the stakeholders, stakeholder participation, wider community participation, and identification of stakeholders. Why are we including the stakeholders if we're not assessing our social performance with respect to those stakeholders? There's the opportunities, the money flows to the stakeholders and from the stakeholders, participation, working conditions, health and safety. These are all important aspects that we could look at through using social LCA. So this is also, as we continue our learning journey here, it would be good to find more examples of social life cycle assessment among the partners. This is all I want to say. I think the good practices, it's an excellent performance by the partners. It's a good start. Some have gone a little further than others because, as somebody once said, they've stood on the shoulders of people who've come before. Others among us have to start afresh. It's good performance, but we cannot stop where we are now. We have to march on, and there are further sophisticated procedures under life cycle methodologies that we can incorporate as we go on in the next few transnational learning journeys. So all I want to say, I'm happy to take some questions.
Thank you, Fritz, very much.
go back
Yes.
to my slide. This is the, this is a bit of an overview of how the current partners are using life cycle methodologies at the moment. So as I said, this is in many ways a starting point also for going on and going further.
This is good. Yeah. We may have some possibility also tomorrow in the peer review sessions come back to these points. Also, if anyone has now opportunity to leave comments or points out. But if not, I wonder if Auli is online from Fortum, so she could. Thank you, Fritz. If no other
Hello.
comments. So okay, so there you are, Auli.
Yes.
Good. If you can, Fritz, stop sharing your screen so
Yes.
that we will continue.
That's it.
Thank you. Thank you. So Auli Westerholm from Fortum. So we have nice opportunity to hear about Finnish management of plastics. So please, floor is yours.
Thank you, Pekka. Hello from Finland. I'm from Fortum, working in Fortum Recycling and Waste. So let's first try to manage this presentation so I can share it to you. So just tell if you see it, because I lose my own picture. Maybe you don't see me anymore, but anyway, you can see
your presentations very well.
Yes, that's most important. Thank you. So hello from Fortum. First, I will tell you something about my background. Fortum is a leading clean energy company, developing and offering solutions for our customers in electricity, gas, heating, cooling, as well as solutions to improve resource efficiency. And our vision is for a cleaner world. Our mission is to engage our customers and society to drive change towards a cleaner world. So this is, I think, all the companies now want to combine their strategy to carbon-free and circular economy. And Fortum Recycling and Waste, where I work, provides circular economy services connected to wastes in the Nordics. With about 40 years experience of waste industry, we are offering a very wide choice of services to our customers. These include total industrial and hazardous waste management, polluted soil treatment, environmental construction, and recycling, like recycling of plastics, metals, acids from incineration, and also industrial lithium-ion batteries. But today, I'm presenting you a case solution for plastic packaging waste and share with you some general remarks about the circular economy of plastics from the point of view of industrial operator. So I'm not a researcher, and either I'm not so deeply familiar with the LCA, but I hope you get anyway some ideas for your work from this presentation. So first I will introduce the current system we have in Finland for recycling of plastic packaging waste. As we are talking about plastics waste, it's very important to note that there are very many different waste streams inside the material group of plastics. Even if we are talking about waste stream called plastic packaging waste, it consists of different streams. There are industrial plastic waste and industrial plastic packaging waste and post-consumer waste, and they are very, very different in quality. And when we concerning amounts and when concerning the homogeneity of the polymers and how clean the waste is, etc. In Finland, we have had for decades a deposit scheme for drinking bottle waste. Deposit is paid back to consumers when they are returning bottles. Currently, most of the drinks are packed in single-use plastic bottles, and the plastic polymer used for this is PET. Return of plastic bottles is currently around 75% of sold bottles, and about 90% of collected bottles are recycled. And this waste stream is clean and homogeneous, so it's possible to recycle the plastic waste back to its original use and produce new drinking bottles from secondary PET. But all other plastic packaging waste, that was the question many years in Finland. And mandatory separate collection, including post-consumer packaging, started in Finland only in 2016. And then extended producer organization called SUMI, Suomen Uusiomuovi, and its translation is Secondary Plastics of Finland. And this SUMI is organizing the collection, recycling, and all other waste treatment, and also reporting and communications on behalf of the producers. And the producers in this case are those actors who are putting packed products onto markets. After 3 years of this system to be in operation, the return of packages is about 34%. And around 70% of these were recycled. And when we count also deposit scheme bottles in the results, so we can estimate that last year's result of recycling for plastic packaging waste was around 30% in Finland in 2019 last year. So these are the statistics I have found from our Finnish statistics. The plastics refinery, as we call our Fortum plastic waste recycling plant in Riihimäki in southern Finland, started its operation in 2016 simultaneously with this new collection system in Finland, which I described earlier. The capacity of this our plant is 20,000 tons of plastic waste annually, and it provides recycling services to the mentioned EPR organization SUMI, Suomen Uusiomuovi. The plant treats all the packaging waste collected by SUMI, and it produces recycled plastic raw materials which have reached end of waste status. And the wastes from process consist of non-plastic materials, non-recyclable plastics, and wastewater sludge from washing processes. These wastes are treated in our waste-to-energy plants. And now I describe a little bit closer the process. The process consists of two separate parts. First step is sorting by polymers. Currently, we are separating 4 most used polymers, which are high density and low density polyethylene, polypropylene, and PET. The sorting is done automatically with near infrared detection. So we don't have any people doing the sorting. It's totally automatic. After sorting, each polymer patch is taken to the actual recycling process, which consists of several steps of washing, flaking, and drying. After this cleaning process, the plastic flakes can be granulated. This means that the plastic flakes are melted in an extruder and pressed and cut to form polymer granulates. Some additives can also be added to reach the requirements of each customer. As you can see in the picture, natural color of recycled plastic is gray when all the colorful packages are melted together. And here you can see some products made of Fortum Circoplastic, which is the name of our recycled polymer. And we are continuously searching for new customers so that all possible products from recycling could have commercial use. We at Fortum are guided by our vision for a cleaner world, so we see circular economy and plastics recycling as integral parts of this vision. And to attend this very vivid and how would you say, also affectionate discussion about different scopes of plastics which exploded more than a year ago. And I think every one of you also noticed this. And we also wanted to attend this discussion. And so we published last year a review where we, in addition of background information and key facts about plastics, discuss about our solutions in solving the challenges that plastics create. And Fortum wants to raise 7 issues in discussions connected to circularity of plastics, mainly concentrating on plastics packaging waste. I will now pick up only some scopes and rather quickly, and I've chosen the topics which might touch the topic of this webinar, life cycle assessment. And later you can read more from this presentation material, also from the publication Fortum's Plastic Review. And in the former slide, you can take the web address where you can find the publication if you are interested. But now I will just go through some topics. Plastics are made of fossil raw oil, as we all know, mostly of them, and it's bio-based raw materials which have been suggested as a carbon-saving alternative for a raw material. And we have been thinking of this possible change, and we see that in long run, this is of course a possibility for carbon-free solutions, though these new materials should be recyclable in the same system than fossil oil-based plastics. And what is also relevant is that as far as we have understood the life cycle analysis of current technologies to make these bio-based plastic raw materials show that the carbon footprint is not always smaller compared to the fossil ones. So what we think is most important is to be able to recycle what we already have and recycle plastics many times over and use recycled plastics also as a raw material for high value products. So this brings us to our next finding, design for recycling. In all materials, but especially for plastics products, the recyclability is mainly determined in the design phase. Short life cycle products like plastic packaging, there can be quick improvements in recyclability if design phase is involved in circular economy of plastics. And Fortum is talking about high quality recycling. And what we mean with this term is that the quality of our recycling products should be equal or near equal quality compared to virgin plastics. This is why we have introduced a new step in waste hierarchy called decontamination. And you can see it here between prevention and reuse. This means that before recycling and reuse, the plastic wastes containing unwanted substances, for example, chemicals restricted in current legislation, have to be separated and destroyed, for example, by incineration. It cannot be acceptable to mix and dilute these contaminated materials into secondary raw material and put them back to circulation. In plastic streams, the examples of this kind of legacy chemicals, which we still have in products, are phthalate softeners or brominated flame retardants. And the quality has to be considered in all steps of waste value chain. Separate collection of plastic packaging waste helps to keep the waste clean from materials, including unwanted substances. Confidence in recycled materials comes with the quality. That's quite clear. As I already mentioned, every piece of the value chain matters. Prerequisite of working circular economy is the genuine demand of recycled plastic. The consumers are starting to look for products made of recycled plastics, but there is still a lot to do. Fortum sees that the solution for the demand challenge, which I mentioned in the former slide, the solution cannot be exporting plastics, for example, to Asia. All Fortum cooperators in plastics recycling are situated in EU, and we support developing enough recycling capacity inside EU to main important circular economy resources in our internal markets. And it could be even a label recycled in EU in some products, so to help consumers to make informed choices. Chemical recycling or mechanical recycling. This is also a hot topic today. Our message is that if we want to save the properties of plastic polymers, we should choose mechanical recycling always when it's possible. In this question, life cycle analysis can bring a lot of new information to the discussions. According to current studies, the general conclusion is that mechanical recycling has the lowest carbon and environmental footprint among the various recycling options. But there is a lot to study in this topic too. There is a global severe concern about the negative impacts of plastics due to littering and marine pollution. Fortum is involved in improving the waste management infrastructure, which is key to solve these challenges. Plastics are durable, lightweight, easily molded into all shapes and available in all color. And plastics is in many ways a superior material. Also, when we think of environmental impacts. So Fortum sees that plastics are necessary in circular economy, but we have to find a sustainable way to use it. So these were some general scopes of plastics, and just to end my presentation, I want to share also my own consideration about life cycle analysis and waste management. I started to think about this when I was preparing this presentation. And as we all know, the main pillar of waste management is the waste hierarchy, which is included also in the waste legislation as a requirement for EU member states. And it's said written in the waste directive that it's possible to exempt from this hierarchy if the total environmental positive impacts of the alternative treatment is bigger than following the hierarchy. And also in EU, all new legislative initiatives have an impact analysis and also at least some elements of life cycle assessment. So it's used in legislation work. But so if we think about this this text, it's the departing from hierarchy which needs life cycle assessment. But my experience is that actually we need even more life cycle assessment or other impact studies to convince that we should follow the waste hierarchy. And for example, this is an information material which we have prepared to support our message that following the waste hierarchy is justified because of CO2 savings. But maybe in the future, if we have succeeded to create a genuine circular economy, it would be the plastic producers who should justify their use of virgin raw material instead of secondary raw materials. So I think that would be really the situation when plastics would hold their value. So that was my presentation. Thank you for listening. And if you have anything to discuss about this, so floor is yours.
Thank you, Auli. It was a very, very nice case presentation, I think. Important plastics is nowadays very on focus globally. And now please send questions and comments now for Auli. Can't now yet see any. If I start, I have one point which I would like to make. What do you ask about an oil? What is Fortum perspective, or what do you think, Auli? In the recent news, there was claims. Well, that was related to waste transport and plastic waste transport in a global scale, and there was in kind of a notes that, for instance, in USA, the oil companies, knowing that burning fossil fuels is harmful for climate, so they are starting to move producing plastics. meaning that more plastics are produced globally, and that in the USA the extra plastics they are now negotiating to transport plastic waste to Kenya, for instance, in Africa, and this waste transport, global waste transport, is of course occurring in Finland as well, and we export waste quite a lot of Asia, and but also treat some other countries' wastes in Finland. How do you see this? Do you see this as from the oil company perspective? What is your idea?
No, actually, we are not an oil company, but of course this is a very important question, because actually the oil production and plastic production, they are combined, because the fractions which are used to make plastics are actually like a byproduct from fuel production. So this is if we would stop using plastics, we could have a lot more some other like wastes. So it's kind of like a byproduct. So and it would be a really it will be a really big change to move from oil society to some bio society. So these are really big questions. But about this transportation of waste plastics to other countries, it's a global problem, and there are now initiatives, legislative initiatives to stop that. There is a global Basel Convention which is now taking actions how to tackle this kind of dirty or mixed or non-recyclable plastic waste to developing countries. And also the traceability at how the waste producers, they have to track and clear the destiny of the waste much more precisely. But of course this is also hard work, and there are always criminality inside waste business also.
Sure. There's some questions now to Auli. Maybe.
Yeah. Can I
yes.
ask a quick question?
Okay, Fritz.
Okay. Auli, excellent presentation. Very good, thank you. I have a question though. The screw cap on plastic bottles. There seems to be some debate as to whether consumers who are returning the bottles should take off the screw cap or leave it on to facilitate the recycling. And so the first part of the question is this true? What is the situation? And secondly, is the eco-design community finally going to attack the question of the screw cap? Let's see, what is your view on this?
In Finland, we are advised not to take the cap off. I think the reason for this advice is because they are of different polymer. The bottle is PET, and the screw cap is polypropylene. Mm-hmm. And so they are different material, but in the process they are crushed and they can be separated. But I know, for example, in some countries, because PP, polypropylene, is very It's like a one valuable polymer, and it has, I think, better value than PET, and sometimes they are collected separately, and they are only collecting. I know that in some developing countries where there are these kind of trash pickers, they really pick these screw caps. So I think it differs in different countries and depends on the process. And what was your other question? Now I forgot.
There we go. The other question was, you had a very interesting slide on eco-design to facilitate the recovery, the recycling and recovery process.
Yes.
Is eco-design taking the screw cap into account finally or not?
That's not familiar to me, because actually we are not, because it's another company taking care of the PET recycling, but there are this kind of tools for eco-design. For example, our European organization Plastic Recyclers Europe, they have a tool for packaging manufacturers, how they can estimate their eco-design of the packaging. So if you are interested, I could share the information about this tool.
I would be interested. Thank you for doing that.
Okay.
Okay, and then yes, there's Elsa's and Raul's comments. So please you can use the microphone.
Yes, thank you. I was facing very serious trouble with the internet, but nevertheless, let's try. Okay, I must say and congratulate you, Auli, on very, very impressive presentation. There's one specific point that rose my attention. That was 75 return on sold bottles. It's quite a lot. And then I was wondering, how was it based upon? Did any
deposit
specific efforts took place, like giving back some money on depositing or other communication campaigns? And also, and it's very much connected with this question, was besides getting all the plastic back and recycling it, now the word is stop using plastic as much as we can. And so what kind of campaigns do you know that are being developed in this context? Thank you.
Yes, thank you for your questions. They were very good questions. And about this drinking bottle system, it's really a deposit system. So when you buy drinks, you pay a deposit of about 20 cents per bottle, and when you return the bottles, then you get back money. And this kind of deposit system has been in Finland in decades already, and it was first, of course, it was first glass bottles, but nowadays nearly all the drinks are packed in plastic bottles. So it's very popular in Finland. If you are too tired to take back your bottles to the shop, it's the children or trash collectors who will take them. So that's why we have reached good results for this waste stream. But that's a question of in plastics discussion. It's that do we hate plastics or do we love plastics? And when we started this recycling plant in Finland in Fortum, there were many people who were really against of this. They said that it's really not good practical to organize this separate collection, and we should get rid of plastics. But then there were actually a national campaign and it was called We Love Plastics. and it was there were very good programs in radio and television and telling about also the positive points about plastics, because there are a lot of environmental positive impacts when we are using plastics. So now I think people's opinions have changed, and that's why we have reached such a high volumes when collecting this packaging to recycling. But as we know, it was still only 34% of all packages.
Thank you. Is Raul? Are you there? Also,
hello. Thank you, Auli, for this great presentation. Very, very interesting. New concepts or concept to take into account, like the contamination step, is a very, very interesting, because we are trying to, for instance, in our regions, construction waste, we need to give the quality versus confidence. We need to push to the managers. It's necessary to give a good quality of products. We need this confidence. I have a question to Auli or Fritz. I don't know how could we policymakers include the social aspect with another kind of type of LCA methods or LCA assessment, because we have somewhere we have another instruments to LCA, but related to social aspect, we do.
I can explain that in a simple way and perhaps follow it up with a separate communication afterwards, Raul. But already we find that in their good practices and in their LCA, there's some consideration of stakeholders. So we say, who are the stakeholders? Who are the people likely to be affected? Much of it is the waste management community, but also the surrounding people. So after the stakeholder analysis, after the stakeholder identification, who are the important people who have an interest in this project or this policy, comes the question of metrics. How do we evaluate the social impact on those stakeholders? The diagram I showed, it had a number of metrics that have been used in other areas, such as income. Does it affect the income of people? It's clear if you put a dirty recycling plant in a sophisticated neighborhood, property values will drop quite significantly. So financial impact is something. Health impact from emissions you don't put dirty plants next to a school, for example. So the metrics have been developed through the practice of social life cycle assessment. UNEP and CTAC and other stakeholders, FSLCI, have published a set of guidelines of how to evaluate social impact from whatever your scheme is. So originally, life cycle assessment was about materials and energy flows. That was all LCA calculated. Then came life cycle costing to say, well, what are the costs associated with it? It's not only the purchase cost, but the operational cost, then the external cost. So after life cycle costing comes social life cycle assessment. That also has its metrics and its own procedures. So it's not so much used as it should be, but it is there and it can be used. And the question is, how do we market it? How do we promote the use of the metrics, the stakeholder identification, and then the metrics? So there are procedures for doing that. There are researchers who are used to doing it. I can send you a link to the technical guidelines for social life cycle assessment. I hope that answers your question.
Thank you very much, Rich.
It's not magic. It's not magic.
Yes.
It's a procedure.
Okay, if I can't see any other inquiries for comments or not, so unless there's no other questions for Auli is at this point. So thank you, Auli, again for your presentation, and it's time to finalize this today's session. Today's webinar, and we have a lot of very nice presentations and ideas for future, I believe. We will continue tomorrow with these LCA topics, and we have case studies also tomorrow about waste management, nutrient recycling, and then we have also analysis of policy system from Finland, and those are those. So we will see tomorrow at 10 o'clock, I hope. So thank you for everybody for joining and taking your time to attend this meeting. And yes, I will have a nice day and see you tomorrow.
Thank you, Pekka. Thank you, everybody. See you tomorrow.
Thank you. Bye-bye.
Bye-bye. Okay.
Bye bye.
Bye. See you tomorrow, everyone.
Bye. See you tomorrow.
Bye. See you tomorrow,
Bye bye.
everyone.
Bye bye.
Bye. See you tomorrow.
See you.